Thank you. Good morning, everyone. Yeah, it's a pleasure to be here. And well, I decided to speak today about the facts which you may have not seen yet about Kotlin. And so let's start. And the first fact is that I started using Kotlin in the times where we use traits instead of interface keyword. And oh, I see knocking heads here, so someone was using Kotlin at that time. Was it the real one? Yeah? Oh yeah, at least one, two. Oh, cool. And the second fact here comes that the init keyword. It was invented a little bit longer from the beginning, and I remember the times I was using where you can create the constructor for a type, and you were not using anything like you can use the brackets to construct anything. I've been playing with that, doing some DSLs. It was really fun. Okay, but let's step back a little bit and let's think about why Kotlin. So back in the years at Jetbrains, we've been doing IntelliJ for, I think, 10 or more years, like 8 years ago. And the IntelliJ by itself and all IDEs, these are all the big Java applications. And we've been looking for a language which we'll be enjoying at Jetbrains to use to develop our IDEs. And of course, by that time, we had experience dealing with the other languages, not only Java. And we've tried several, and they figured out that these are all good, but not good enough for us. And that was the reason we've decided to try and to create yet another language and to see whether it will work good for us or not. And this was the reason we started doing Kotlin. And it turns out that we were trying to make the Kotlin concise, so you write less. Of course, you filled this. It is safe, so the type system is safe, and the null checks, and the compiler helps you to make sure there is no problems in your code. And if you're dealing with the null references, the compiler asks you to clearly check if something can be null explicitly beforehand. And the interoperability was one thing for us as well, because if you have like 10 or more than 10 years old Java application to develop, it is hard to say, oh yeah, let's rewrite it in a different language. No way. It is too hard, and you'll waste time doing this. Instead, we invested in their interoperability, so you can mix Java classes with Kotlin classes, and it is the way to go further. It is exactly the way we try to do with our MPP, where you have a multi-platform projects, and you can say, okay, here I used Kotlin, here I used Swift, here I used Android SDKs, here I used my favorite JavaScript libraries, and so on. Interoperability is a good thing to have. And the last, I don't know how you would feel, but if someone would say me, here comes yet another language, would you try it? Sure, I would. But without the good tooling or the compilers or build systems or an IDE, it is way harder, and it is clear for us. And we try our best to make the best tooling for Kotlin as well. And these are all things we had together to start. And then we started. And the first code name inside, it was something around 2010, 2011. The language was called Jetlang, or Jet, with extensions .jet. And it was not released with a Jet name, but you may remember it from the XML files, like, for example, this. So after the Kotlin, the name was changed, you may have seen this in the settings, code settings files under IntelliJ project file system. It was there for a long time. And then by the time of the first announcement in 2011 at the JVM Language Summit, we decided to create a code name for a language, and it was Kotlin. So Kotlin essentially was the code name. And we start using this logo first, or that one, or this logo first. And then we switch to the logo on the left. So this was the beginning. And the extension, we decided to use .kt instead of .kot because of the possible translations. Well, this was the public announcement, and in several years, we've been happy to release 1.0. And by that time, team decided to keep the code name as a real name for a language. So now Kotlin is Kotlin. It is no longer a code name. But wait a moment. What else can we find about Kotlin? And this year, in 2019, if you're looking for some information about something, you technically use the search, right? And I decided to do the search. And here comes the fact for you. So if you Google it, and you'll see this. And if someone would ask you, can I run Kotlin on somewhere else? Remember this. Just remember, now you can run Kotlin not only in your JVM, Android, iOS, and so on. Here comes yet a huge set of possibilities. Well, fair enough. And then I continued Googling it, and I realized that this one comes from the region in Poland. And there is a picture, this kind of a picture. If I'll be traveling somewhere there, I'll definitely make a selfie. And probably this one. This is Georgia's one. And this is actually a train stop somewhere in the middle of the Poland. And wow, I was happy to figure out there is a place like this. And yeah, technically on the map, it is somewhere there. And of course, there are many, many other things which are named Kotlin along the way. And they are not, like, there are so many things, so I decided not to put it here. But let's go further a little bit. So what we have here are somewhere in 2014, we've created the kotlinlang.org website with the documentation, information, anything around Kotlin, right? And we've been using this first picture with the old logo, but it makes, unfortunately, no sense right now. The sense comes here. This is the second design for the website. It stayed long enough and I remember this one. I think we changed that one somewhere around 1.3.0 release last year. And the interesting thing here is this lighthouse. And this is a wooden lighthouse, and it exists. If you Google it, you'll find a picture like this, or you may find a picture like that. So this is an existing thing. And even more, this one exists on an island, which is called Kotlin. And then this island is not far from St. Petersburg. And this was actually the reason for us to name Kotlin, and here comes the proof. It's always good to prove something, right? So the proof is as follows. So have you tried the Kotlin in Action book by Dmitry Zhemerov and Sveta Isakova? Yeah. So somewhere in the beginning, in their introduction, it says that the Kotlin was named after an island near St. Petersburg. And I have yet another fact. The lighthouse picture from the Kotlin website, it was Dima Zhemerov who did this picture. So actually, the Kotlin team contributed to this picture and created this thing. Well, so here geographically, right now, our Kotlin island is located not far, like 32 kilometers away. 32, interesting, right? From the actual location of Jetbrains office. By the time they created this name, I think it was not 32. But now, as far as I computed, it was so. OK. Good, is it? But I think it is time to warm up. And we are here, and let's solve a puzzler. Actually, it's not a puzzler, but let's warm up. All right. And I think it's easy to get the answer to this one. But if you're uncertain, here is a solution. You may use play.kotlinlang.org, and you may type your program even from a mobile phone. Even if you have a Wi-Fi connection here, you might type it, and you'll see what it does. And here I made a mistake on purpose. And the next thing which I would ask you, what will this do? So again, we are doing the warm-up, right? And let's think. So the question is first, what type is it? What type is inferred for it? And the second one, what will it print? And so if you have your laptop open, you can navigate the character on the left side from this plus symbol somewhere here. And then you click Ctrl-Command-B, and you will jump to the declaration of this operator. And it is declared as follows. So we see that in a standard library, we have the extension function operator plus on strings, which takes nullable string, something else that returns not nullable string, right? OK. And the Java doc says us that we tend to use the quoted null for a null value. This is the way how we represent nullable strings, right? And so this is what we have now. So now it's more or less clear what it does, is it? OK, so, and this is a very interesting thing about the explanation. And it's a good tradition, I think, that if you use JVM and I think in many other languages, if you try to turn null into a string, you'll have null quoted instead of empty string, instead of crash, instead of anything else. And we all got used to this. It's a good behavior. It's a good way to see a bug. And it's a good reason to have an email saying like, hello null, or dear null, or you open the website or something and you'll see null instead of your name. Wow, good, is it? But they know it is a bug. They'll fix it definitely. But now they see it, because otherwise you'll see hello, white space. Am I a white space? No. Because anyways, you have a hello, then white space, and then a string which may not be represented in any ways. So speaking about our puzzler, do you see the solution? Do you see the answer? Here's the answer. The answer is that the type is string, and the value is null null. Good morning. But I'm here to fix this. And the fix is as follows. I will tell you nothing about nothing here. But if you do so you create an operator which takes nothing and something else, and it is enough. This is definitely enough to fix it. So we'll have this at the end. So the yellow highlighting says us that this code is not reachable. As long as it is not reachable, OK. So the compiler knows. The compiler tells us, OK, something goes wrong here. And defining this, making this return nothing, tells the compiler that this one will stop working at this point. That's a good thing, is it? If I try to add the null with something else, it's good to make it not working. And it is the point for us to speak about nothing. And now I tell a little bit more than nothing about nothing, but it will be about nothing. So nothing is a type in Kotlin, which is a subtype of anything. Any type you have, nothing is a subtype of it. No matter if you have a final declaration somewhere, no one cares. It is a type system of a language. But the second fact is that nothing means the execution will stop, because you have no values for type nothing. The only way to return nothing is to throw in an exception, and that is it. And it gives us a power for idiomatic programming and a shorter expression. For example, you may create your own assertion. And it's good if an assertion has some parameters to assert. But in my case, I simplify this. And now the compiler knows, OK, as long as I've done this assertion, it returns nothing. So it means that there is no way further. And the compiler tells me, oh, yeah, it is a stop point. It is return kind of a thing, or an exception. Good. And we have more and more expressions for nothing, like this one. Like return statement has type nothing, throw statement has type nothing, throw expression and a return expression, and a to-do function, which is the standard function from the standard library. And we can create our own extension functions or extension functions returning nothing as well. And it gives us the power. So for example, I start doing on something else. I start hacking on their application. And what I do, I create several functions, because I need these functions to code something here. And right now, I have no idea how I would implement this, but I need to code here. That's why I create these functions, and I say return to-do or equal to to-do. And their types are good, because you have to specify types explicitly here to make the rest work in the right way you expect it to. And now I can flip and hack. And then I have a code like this. So, oh, yeah, let's find something, let's check it. And you see the gray highlighting here, do you? I think you do. So, and the gray highlighting tells that there is something you can improve here to make it a little bit more idiomatic. And what we do, we click on this light bulb and say, please fix it for me. And like the example above, the example below, and we may use Elvis operator with nothing, like this. And it is the shortest way. So you say, OK, fine. I would like to find my item. If it is null, OK, I'll return. If the info is null, OK, I'll throw an exception. And as for the type system side of view, these all expressions have type nothing. And it means that the type on the left is their more common type than nothing. That's why it wins. And of course, if you would like to do a shorter program, you can do it like this, but sacrificing the behavior in this particular example. Or you may do it like that. You may say, OK, I will use let, try and be functional, to solve the same thing using the Elvis operator. So the fact is that if someone would ask you, how would I make my Kotlin code a little bit better? Well, you may say nothing helps you. Actually, nothing type helps you. Use nothing type. And use the IDE. So in IDE, there is a box in the top right corner. If it is not green, and if there is no green tick in there, it is something you may try improving in your program, if you like, of course. Warnings are good to fix. And now, I would like to say a little bit about the interfaces. So in Kotlin, it is possible to create an anonymous object which implements as many interfaces as you like. And of course, one base class if you like as well. And it gives you a little bit trick. If this interface, this object is declared in a private visibility, you can clearly access the fields or the methods of this object directly without any type. Because for this anonymous object, there is no exact type. You cannot name this type. But you can access the fields as long as it is private visible, not the public visible, because you cannot name this type. And it gives you yet another way to simplify your programs somewhere, like to make it shorter, because you no longer need to extract this type or create an interface to solve the same problem and same intent. But how would we implement an interface? Of course, we know how, and I will not be explaining how, but can we implement an interface without implementing an interface? Essentially, we can. And let me have this interface for you. And now we start doing this, and there are many, many ways to do it, and I decided to go with a Java lang reflect proxy. And behind the scenes, in many frameworks, you may see that it's doing something for you, the same similar thing for you. Why? Because an interface can be coded. The way how you create it can be coded. And you actually don't need to spend your time or someone else's time to implement this one. OK, so the idea here is that you pass the interfaces which you like to be implemented, and you pass the invocation handler, or this one in the button. The invocation handler will be executed all the time someone is calling something on your interface. So we can implement this invocation handler with an object expression like this. OK, anonymous object. It is a long thing. And you see this highlighting here again. So now let's flip it, and let's simplify it. And we can use the SAM conversion. So you just name the interface, which comes from Java, and you just turn it into a Lambda this way. And it works for all functional interfaces, which you've seen around. And it makes your program shorter. And of course, you instead of proxy method and args, you may say underscore, 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 like in my example. It will be shorter again. And my intent is here to throw in an exception. So I would like to have a proxy, the implementation for my service interface, which throws an exception for every call. It may happen, right? So this is how we create the service. We call this API. We pass all the handler, the type, and then we cast it. So now we have a service. And now it is a question for you. So if I would call it, what will it do? So we expect it to throw an exception for us. But what will it do, actually? And the fact is that it will call our invocation handler. So I call the method. It goes through the internals and jumps into this handler. And here comes a surprise for you. That is that. It turns out that the proxy implementation tries to protect you and tries to follow the way how we code with Java. And in Java, we have the checked exceptions. And the checked exceptions means that you have to, I should have declared this exception in my declaration, but it was the Kotlin interface, so no declaration. But it throws an exception. And this exception is wrapped with a runtime exception. And fine, it's easy to fix. So if you add the throws annotation, you can have this throws declared on the JVM bytecode level, and it will work. So the fact is, if you deal with proxies, if you try to implement an interface without implementing an interface, which is awesome by default, right? Make sure it works in the way you expect it to. Sometimes it may misbehave, and it is good to check it. It is good to try and see how it works in fact. OK, but how generics are implemented? How generics work? This is the next thing which I decided to cover. And there is type erasure behind, meaning that anything you have with your generics, it is gone. It is no longer present in the bytecode. Don't you trust me? So I've created an example for you. So I have a generic function with their constraints, and it returns a list from string, right? It calls something on the runnable type, runnable interface, and it calls the to-double from a number. And now, tell me, do you know this trick? So what I do, I click Command-Shift or Control-Shift-A, and I pick the action, which is show Kotlin bytecode. What is this bytecode? It is the Kotlin compiler. It compiles my source code into JVM bytecode class file. Then I click the decompile button in the tool window on the right. And what it does, it calls the Java decompiler to decompile this bytecode back into Java, not in Kotlin. What's the reason for it? The reason for it, you may see how complicated things are implemented at the lower level. And here comes the answer for you. So I've compiled and decompiled this generic function, and now what I have that the type is now number. It returns just a list, nothing else. So no generics anymore. And in Java, you can use generics without angle brackets. It is allowed, because they try to be compatible with Java 1.4 and less. So not breaking things. And when I need to call the runnable, the cast is included into this call. This is how it works. So what we have, the type erasure, actually, it removes all your type parameters from everywhere, and it puts their most common type, in most cases just object or something. Then it inserts casts in the place where you use it. It inserts casts in the place where they are supposed to be. And even more, if you implement a generic function with a fixed parameter, it may even generate a specific methods for you to make it work truly as you expect. But there are no generics. There are no generics out there. And here comes the thing. When you see the fact that you're trying to cast to T in your generic function, and you see the highlighting saying, probably it's not the best idea. Well, indeed, it is not the best idea, because the cast will be evaporated. You'll actually not be casting to anything. And sometimes the class from T and the cast method will help. From the other side, the refined generics in Kotlin will help. And let us see. So I've done yet another example. I created two functions. The first one, cast, and the second one, refined cast. The first one is just a generic function without anything. And the second one is inline function with a refined keyword in the middle. And it's for purpose. So what we have here is that now I have two statements to execute. So the hard cast and refined cast. And it is for you to tell me, will it crash? Just think for yourself. So this is the answer. Actually, the first one will not fail. It will work. Towards some point where you explicitly require some type, and then it will probably crash a little bit later. And this is because the cast is erased, so there's no more cast. And from the other side, the refined inline function is in line to a call side, which means that it is in line. The types are substituted, so we called it with an int. And now it knows it is int, so it replaces t with int. And then this is what we have in their call side. And in this case, it will fail. It will definitely crash exactly when you're trying to call this function. And this function is inlined. So with a refined inline function, it inlines the type parameters. It inlines your lambdas, if you use lambdas, not like myself here. And it helps to deal with this. And if you're doing this in the right way, you can create a function load, for example, which takes a string and a type parameter. And this is a way how you may deserialize your favorite list from strings, or list from map from list from, and so on. So you can do it. And the trick here is that when you have a refined inline function, if you create an anonymous object inside, it will be inlined in the place where you call it. So you actually have an anonymous object with their specific type parameters included. And this is a way how you can simplify the deserialization stuff like this. OK. And well, it was the hard part, the hardest, I guess. And now let's speak a little bit about the curtains. The curtains are stable from 1.3.0. And here comes in the Kotlin X curtains library. And the fact is that this is a library. So it is good you use this library. But if you don't, you can create your own library. You can use suspend functions and suspend fun in the way you like it. And there are so many modules included in Kotlin X curtains library. So you may pick the best combination of these to fit your need. I will not explain how it works, but I'll show you several interesting examples. The first one, I have a function with a callback. And what I need to do, I don't like this callback thing. I don't like to be moving the brackets to the right along the way, so I'll try to fix it. And the first fix could be, I can create the suspend function, and the fact is that this call fun is just returns my string. No matter that I'm still calling this the callback function and I have this callback inside. So technically, the suspend coroutine function, it helps me to change the call stack with a callback. And once I have a callback, I can flip it into my function with a callback. Good, is it? Now I have my program simplified. And I can go further and I say, OK, if I need this function to be like just an ordinary function, not a suspending function, for some reason I just use run blocking. And I call my suspend function. So to summarize, I can do this following pattern to flip a callback HAL into an ordinary function. And sure, we should understand that there are side effects of it, like the suspend coroutine or suspend cancelable coroutine. These functions are good to flip their call stack with a callback. It is a good way. But run blocking is the function which you may probably not be using because it may slow down things if you use it just randomly. But if you use it in the right way, it will help you. The last, argument, right? Oh, cool, yeah, I've used this one. Why? Because it was easy to code? Was it bad? Could be. But if you think it's something is slow, profile it and see. Don't trust anyone. And me, don't trust me. Our stack overflow. Actually, I'm referring to this. And they're probably with a white space in the middle. I'm not sure, but the exception is called stack overflow error without white spaces, right? Well, have you seen this before? Yes, I think so, right? And what we can do out of it, besides the obvious things, we can extend the stack size. We can do tailrack. The tailrack keyword in Kotlin, what it does, it says, if your recursive function is tail recursive, meaning that the last call is the recursive call in the function, you can ask the compiler to solve it for you. But it's complicated. And if you don't trust me, try checking how to implement the Fibonacci numbers with tail recursion. It is possible. It is tricky. And the last, and the most powerful thing is to replace recursive calls with their loops. So actually, you implement some kind of a stack locally in your code to solve it, right? Well, I decided to do a deep recursion. I decided to think that I have a specific arithmetic, and the only way to call the sum is to use recursion, right? It's a good thing. So how you call the sum of numbers? You take the one, and you increment the result of their recursive call, the standard thing. And of course, if you call it with a big enough integer, what do you see? You see the same picture again. And I decided to look for a short solution to this problem. And I'm happy to show you this thing. I don't know, hack or feature or something. But I'm happy to show it to you. So actually, I spent 2 keywords to fix the Stack Overflow problem. What I've done, I've used the suspend keyword for this function, and I used yield. The yield function, Kotlin X coroutines, what it does, it simply stops the execution, meaning the free in the stack, turning the stack into a callback. So the stack is free. There is no million of calls in the stack anymore. And then it schedules this resume into the next call. Actually, it makes the compiler to implement the whole magic for me. So I no longer need to code it manually. Instead, I can use it with the coroutines. So as for wrap up here, the yield function with the suspend keyword, it helps. Run blocking, be careful here, because again, it can be slower than you expect it to, because run blocking is supposed to be worked with a multi-threaded context, and it may slow down things. But don't trust me, trust your profiler. And the last thing, of course, the better explanation. It was so easy to code. That's why I coded it that awesome way. Awesome way. Yeah, OK. Yeah, and if you would like to go further and learn more about coroutines, I think this is a good video to see. But apparently this video, not from this year's conference, but from the previous year's conference, of course, not from the future. OK. But the logo is good, is it? OK, the building with Kotlin. it is good to build something new with Kotlin. It is good to try using this language to solve any new problem which you have around. And there, for me, it was interesting because I figured out that this was the problem I was looking forward in the try. And it's called the Conway's game of life. So you have a 2D space. Every cell in this space can be either live or dead. And then they give a really easy evaluation rules. And then we try to figure out how the thing behave. And the evaluation rules, they are really easy. The color of the pixel of the next iteration depends on the neighbors of that pixel, nothing more. And it exhibits such an interesting behavior, so I decided to code it and to give it a try. And I created these rules, and the rules are really, really easy. I decided to even use the extension function here. So the evaluation cell, this is an information of a cell which I was looking for. And actually, I need the state of this cell, and I need the number of live neighbors. And the rules are this. So actually, as far as I read in the Wikipedia, Conway figured out this game of life, learning some biology systems and the behavior in the populations. And then I created this app. Like, I created the maze, I created the function to print it and to iterate it. No magic here, it's just a programming kind of first-year grade assignment for students or something. And then I have this picture. And this is an example where you use emojis, because it is emojis, so I was lazy to implement. This is a console app. It prints emojis to render the whole thing for me. And then I can show this information. Actually, this pattern is known as a glider. It moves towards the back, towards the bottom right. And you go up on Wikipedia and see other patterns as well. And then what I've started trying and hacking it. So I've used the same code, exactly the same code, and I compiled it with Kotlin native. It is 1 megabyte binary, which requires no JVM, nothing, but it works the same way. And apparently, I figured out that the console, like in the macOS, it is not so happy about the Unicode images. It is not able to render it in a good way, so I've used the IntelliJ console here to show it. And as for Kotlin native, it's done pretty great. So no virtual machine, so you click run, and it is immediately runs. It is LLVM backed, so it targets all the platforms, many, many platforms, including all desktops, the Raspberry Pis, Android, and iOS. And the Kotlin native is included with the Kotlin releases as a beta. So you might be probably up to date if you want to try this one. And it can create an executable for me. It can create a framework, a library, or dynamic library, or static library. And it can consume C headers. It can consume Objective-C declarations. So it's pretty easy to use it for the place. And then I was told that the console is not that good. And I decided to try browser console. Apparently, the browser was really good at rendering Unicode. So I was able to show the same thing in the JavaScript. So I've picked the same source code. I've used Kotlin.js compiler, and now I have a JS binary. Works. And then I created this UI. Oh, again, I still rendering the emojis, but now with a pre-tag in HTML. My experiences in HTML was enough to solve it, happily. And I was happy, and then someone told me, oh, yeah, but there's supposed to be canvas in JS. It's a cool thing, is it? Fair enough. I decided to give it a try. So I wrote this whole thing. But essentially, the meaning is here. All right, so I've done this. This is a tiny add-on done in Kotlin.js. And what I do, I get my canvas element, I ask it for the context, for the rendering context, and then I render my picture just into the canvas. That is so the most part of this slide is the math, how you would render the ellipses or the bounded rects on this picture. And then I realized that I can use HTML DSL from Kotlin X HTML library to render my HTML. It is not React. It is just one snippet of code. And it was definitely enough for me to solve my pain. And actually, I can even subscribe for functions in there, like the onClick function, and I can pass a lambda there with Kotlin.js. So actually, I've done no JavaScript, but I've created this app. And now it is able to show me the picture with the better picture, not the Unicode images. And then it's come to mobile. And I realized, oh, mobile. Can't I do mobile? Well, I can. And I can do the Android, I can do iOS. And I decided to give it a try with Kotlin native and iOS. And here comes the idea. So in iOS, what you do, you compile your Kotlin code, essentially the same Kotlin code as the framework for Objective-C and Swift. Then I use this framework from my Swift. And I'll show you something interesting here. So before I do it, oh, this is the diagram, so actually how it works. Like, you mix it together, you have the framework. The framework is the way how you call the library in their Mac ecosystem. And then I have my rendering running in their Xcode. Essentially, if you have something printed into the standard output, you run this into iOS simulator, you'll see the console. And you're, oh, yeah, that's a good way, is it? Now I can use my iOS to render the game of life. But definitely, it's not the best way. And so I decided to hack it. And trust me, I don't know how to do iOS. That's why I use UI label. And I tend to use images. I'm happy images are around now. Now I know the reason for them. And this is a bug icon here. Wow. OK. So I use it. And here comes the solution. And I enjoy this, because I've created a tiny wrapper in Kotlin side. I have the event like, the world changed. It's an awesome event, is it? Can I subscribe for it? Well, and I subscribed for the event on the change of the world from the Swift. So actually, I passed the Lambda from Swift as a parameter to Kotlin. So Lambda from Swift and the Lambda from Kotlin, they're connected together. And now I can render my picture, and I can show this. So I can have the same app, essentially the same code, running iOS. And my kid was happy playing this game now. So, and the last thing, and if you're listening to me clearly, are doing the JavaScript, sometimes you require to have a web server to make your browser happy. Browsers are not happy running some random JavaScript without a web browser, without an HTTP server. The second thing, I was showing you this good animated picture, and I was looking for a way to render this one. And for these reasons, I decided to go with the JVM. So I've created the Kata web server, because it was the easiest way to create a web server. And I rendered the GIF image. So I've been using Java AWT to render the GIF and the images. It is a buffered image. It is the standard APIs. You can extract the graphics, and you can use graphics to render the picture. It is so easy, and we all know how to deal with it. And then I created the GIF. So here, it's actually, I have this cool function, create GIF. And you may open the repo and find how I do it, but it's Googleable. And there is an APIs in Java embedded, so you can render your GIFs. And this was the way how I created this whole thing together. So I've been using the same algorithm. So it was like hours or so to invent the rendering thing. And then I spent way more time to port this one for all these platforms, actually, without rewriting the whole rendering idea. It was good. It was awesome. And it was a game of life example. If you would like, you can contribute or take a look. It's on my GitHub. It is available. And I've been using the Gradle DSL for the project. I've been using Kotlin multi-platform plugin to implement the whole project ecosystem. And it's like JavaScript. It supports JVM backend, console application, HTTP server, native app running for a console, iOS with native, and even more. And this was an enjoyable thing. And to summarize, it implements this picture. And if you see something missing on this picture, please contribute. I mean that I was lazy to implement Android part. That's shame on me. OK. So at Jetbrains, we use Kotlin in mostly any projects, because we have so many projects which we do with Java for JVM, server-side, desktops, and this all is using Kotlin inside. It depends on the team how many things they're using, yeah, I should have mentioned that we have more than 50 people involved in Kotlin in JetBrains as well. Oh yeah, and I really like this slide. And for example, here there is a toolbox. This is a tiny app to help you to install all your IDEs, and it is using Kotlin, but on the server side. Sorry. And OK, a crazy example for you: the Rider. Have you ever tried doing the C# development? Oh, it's the wrong conference, is it? But never mind. The Rider IDE, it is their IDE which is based on their IntelliJ platform, right? So it's huge Java application from one side. From the other side, the C# development, we use the C# ReSharper, which is the plugin for Visual Studio which we do for C# development, which is written in .NET. When you come to Rider, what you have, they use Kotlin to code all the parts from the UI side. So the Rider is IntelliJ and their Kotlin part, which is written in Java, to do the all UIs. Then they spin up a small .NET part to implement the brains for your IDE. And they use like 100% Kotlin code in there. Awesome idea. OK. Oh, yeah. Have you ever tried doing the college programming contest like ICPC? Oh, yeah. Now you know that it is possible to hug the solutions with Kotlin as well. So this fall will be the 3rd year when people are able to do this. Isn't it great? Actually, I like this picture behind as well. Oh, yeah. And the last part, no matter how you would read it, but we have several people from Kotlin team today here, just behind these doors. And we are happy to speak with you. We are happy to help you. Should you have any troubles or questions around Kotlin, around MPP, just step by and say hi. And besides that, we have some pins and stickers in there. Yeah. Oh, by the way, yeah. This is it. They can help you if you have questions, and we will be happy to speak with you. And actually, to the wrap up, just use the Kotlin, learn it further, try different things, and definitely expect fun. But be careful with suspend. Thank you.